Hey everyone, welcome back to another video. Today we're going to tear down and inspect a Ford C6. This is out of a 1986 Bronco. It's a 4x4 unit. So customer brought it in, indicated that he would like the transmission refreshed, torn down, and if necessary upgraded a little bit with a shift kit. He did say it was working fine, but he's going through some major engine service work, and so he's kind of trying to refresh the powertrain as a whole. And we may even see the transfer case. He had talked about maybe bringing that to me and kind of doing the same thing as well. So quick history on the Ford C6. Began production in 1966, had a 30-year production run, and was superseded across all makes and models in 1996 by the E40D. Insofar as consumer lines, the C6 was replaced in 1989 by the E40D, both gas and diesel applications. So it's a great transmission, very, very reliable, durable, can take a ton of punishment, and overall, if I had to train somebody new that is not familiar with transmission building but otherwise mechanically inclined and motivated, I would teach them how to rebuild a Ford C6 and maybe like a TH350 and move them to a 727. I think all three of those transmissions make for great introductory platforms for somebody new to the industry to get started on. All right, so we'll do a quick walk around. I'll show you some, different things. I guess a combination of trivia, history, as well as need to know, and then we'll get into the teardown. All right, so the first thing I'll talk about is the casting ID codification that's stamped into all of these C6s. And I'm going to mention this because if you're building C6s, a lot of times you'll have a unit that is coming out of a vehicle that it wasn't originally installed into. So for the purposes of both swapping parts, looking for compatibility or interchange, it's a good idea to know where the transmission came from originally. So there is a series of alphanumeric stampings here across the driver's side, rear of the case, just above the pan rail. Let me zoom in and we'll go over those real quick. All right, so you see here you have the letters RF followed by a dash, and then the letter D, the number 7, the letter U, and the letter P, followed by a 4-digit number that is reads 7006, and then followed by another dash, and then a series of letters. This one happens to read AA. So this is what all this means. RF simply stands for reference. Okay. Now this is where you're going to tell the year and the I should say platform. It's a combination of make and model, as well as the design office responsible for producing this part. So D is going to indicate the decade that this transmission was produced. So there's 4 different letters. There's going to be C, which is indicative of a 1960s unit. D indicates 1970, and then E equals 1980s, and then F is a transmission produced in the 1990s. All right, the number or integer is going to indicate the specific year of production. So D7 would correlate to a 1977 model year unit. U is going to tell you what the platform was. So there's a whole bunch of different letter and platform combinations. I'll put a chart on the screen to show you, but U is going to be indicative of an Econoline van, so it's basically a van transmission. And then P is going to indicate the design office that was responsible for this component or part. P simply stands for automatic transmission. Okay, the 4-digit number here is just simply going to be the basic part number. And then your last 2 characters, which are going to be letters, you may have a single letter or you may have a double letter like this. That is a form of versioning control and indicates what iteration this transmission represents. And as far as I know, every single part where there was a change of some sort of design or engineering variation or evolution, it got a different code here. So anyway, that's how you can tell where the C6 that you're working on came from. So clearly this came out of a van, probably a 351 Cleveland or Windsor. The Bronco in question has a 351 Windsor in it, so it's obviously compatible. So let me zoom back out and we'll talk a little bit about the bell housing and a little bit of what C6s were installed in, and where you can kind of go between platforms if you need to swap transmissions. So there were 4 distinct bell housing bolt patterns and shapes that came on the C6. So you had your big block 385 series pattern as well as your IDI diesel. Those were very, very similar, in fact identical to each other, other than the fact that the diesels had a cutout, kind of a half moon cutout here at the bottom of the bell that the 385 series big blocks did not have. Okay, those same or that same bolt pattern rather was also installed in the modified tall deck small block engines, so your 351 and your 400Ms. Then you also had your small block bolt pattern, which is going to be typical of your 302s, your 289s, your 351s, Cleveland and Windsor, that were not of that tall deck variety. And then last but not least, you have your FE series big blocks. So those are like your 361s, your 390s, 427s, etc. All of the bell housing bolt patterns feature 6 bell to engine block bolts. Okay, so this is going to be your small block bolt pattern, again squared off, and then your FE series big blocks are also going to have more of a rounded shape. So obviously you can't mix and match bolt patterns on the transmission with those on the engine, but that should give you an idea of what is available from a bolt pattern perspective. All right, staying here with the front of the transmission. All these Fords, C6, E4, D4, 100, 501, 10, have what I call a floating input shaft. So when you're looking at the input shaft, you obviously want to inspect it for damage. You want to look at the splines, but notice that the splines that face inboard are nearly twice as long as the splines that face you, or face the converter. All right, and of course you have a shorter journal, so it's very, very difficult to mix that up. We're going to leave this in the transmission for now because we're going to do an end play check on the gear train, or the relationship between the gear train's travel, including the drums, against the backside of the pump. The pump has a selective washer that goes for thrust purposes, and there's various thicknesses. Again, I'll put a chart on the screen, but it's a good idea to get an end play reading on teardown for these units, as well as the Dodges or Chryslers, so that you have a good sense of what you're working with when you go back with it. And unless you're making major changes like swapping the case, swapping the entire gear train, maybe you're putting a 4R100 gear train in these, which is a popular upgrade, you shouldn't be wildly different in terms of your overall travel when you have the case fully reassembled compared to what you measured when you tore it down. All right, looks like we have some metal parts or kibbles and bits in there. I don't know where that's from. All right, we'll get more into the pump once we ultimately remove it. Let's move on to the servos. So a variety of different servos and cover combinations installed in the C6. The most popular for racing or high performance and has the largest apply area is going to be your R code servo cover. So servos and servo covers are a matched set. So regardless of internal dimensions, your inner diameter of the cover and the servo, you need to know what cover you have so that when you replace the servo piston, you get the correct piston for that cover. Okay. There's also billet and high performance servo cover combinations on the market. The one thing you want to be cautious of, and I'll get more into specifics when we get into the case and start talking about the front band. Well, there's only one band in this unit. Is you don't want to get super aggressive when it comes to the servo size and the band lever ratio. Okay, you don't want to go balls to the walls because that can result in everything from a snapped or broken band to a cracked case. All right, again, I'll get a little bit more into specifics and flash part numbers and charts and whatnot on the screen when we get to that point. All right. Extension housing, they're just like any other extension housing. 6 bolts hold it on, 9/16. I'm going to try to get away with using a 14mm socket on here because it's like a wobble. If not, I'll have to resort to the 9/16. And then you'll notice here on the linkage, the inboard, or I guess inner linkage rod, is still on it. These require special pliers to remove from that grommet. So if you're not sure what those pliers are, they're made by OTC. Okay, it's going to be T67P-7341-A, and these are specifically designed to get in here, in behind, between the grommet and the case, or I'm sorry, the stud, the case, yeah, the stud, to take off this lever. I'm not going to do that unless I have to, but in case you were wondering, that's what they're for. Transmission mount, always replace the trans mount. I mean, this one's all tore up, but the socket size you'll need is 3/4. This is going to be your band adjustment screw and lock nut. This is going to be 13/16. Again, we're going to leave it alone for now because I want to do a case air check once we have the valve body off, just to get a sense for what the situation is with the clutch packs, making sure that if there are any problems, then if he does tell me that, oh yeah, it did this, or yeah, it did that, I can kind of tie that to a symptom or an indicator that might appear on the air check. All right, some C6s had these fins. The diesels and the big 385 series big block had cooling fins here on the back. And then they started to add them here as well toward the rear of the case by the extension housing in later years. All right, vacuum modulators, always replace them. So 1/2-inch bolt on the modulator, 1/2-inch bolts here, pan gets 1/2-inch bolt, or 1/2-inch socket I should say, and likewise for the pump. Now he did pressure wash this transmission just before he brought it to me, just got most of the gunk off, or a lot of it anyway. So we're probably going to see a little bit of moisture when we get in here. That's what that's from, no big deal. Any surface rust can be removed either by wiping it with WD-40 or gently removing it with like a wire wheel or something. All right, I'm going to start over here with the servo, just get that out of the way, and then we'll again proceed to the extension housing, modulator, and then kind of work our way like usual. So 1/2-inch. All right, sometimes these will come off, but most of the time you're going to need to persuade it with like a hammer and a screwdriver. Just be real gentle with it. And I like to go to bolt hole location. Okay, you don't want to force anything. You obviously don't want to break the cover. So you're going to have your return spring, and then you're going to have your servo itself. The servo is always replaced on overhaul. So from a diagnostic perspective, if there was any issues slipping in second gear, you want to check the lips. These sealing, both of these lips on these sealing surfaces are actually pretty hard. So I may ask him if he had any issues whatsoever in second gear. He may have, he may not have had, but those are rock hard. Okay, then you have an O-ring right here. You can get that out. Okay, I call it O-rings. Actually a square cut ring, but I call these kind of seals O-rings just out of habit. All right. Put these to the side. I have the servo cover cleaned off, so let's take a closer look at it so I can show you what an acceptable wear pattern looks like and what to look out for, so that if you see it, you recognize it and you know that you need to replace this cover in the event that you observe these things with your servo housing. So first off, here's the servo code. Hey, it's a lot clearer to see now than it was when it was all caked with mud. It's always going to be here on the rearward side next to this little bump out formation. On the inside is where you really want to scrutinize. Okay, so here's your apply side. All right, this smaller inner diameter is the apply side that's going to vary from servo to servo, and then you have your release side here. You want to make sure that regardless of what you visually see and observe, you cannot feel anywhere whatsoever, anywhere on either of these two inner diameters. Okay, if you do, then you're, depending on how severe it is, if it's really super light, a little bit of maybe 800 to 1000 grit sandpaper, a little bit of transmission fluid, or WD-40 will clean it up. But beyond that, if it's anything that it's catching your fingernail, like when you're going like this, all right, then you want to replace this cover. The last thing you need is to have scoring inside one of these diameters start tearing at the sealing surface on the lip seals of your new servo piston. So this is what I typically will see in an otherwise healthy cover. All right, you see some visual scoring, right? It looks like there's something there, but it's just a wear pattern. So minor amount of particulate matter is passed through here, both the apply and the release side, but there's nothing in here that I could feel. I mean, it just feels mirrory smooth, and that is exactly how it should feel. So I have no qualms about reusing this cover. Obviously, we'll acquire a new servo when we go back with it and install the new servo, but the cover itself is in good shape. All right, and then we'll replace this, this seal here. So anyway, this is a critically important aspect of the teardown inspection. I didn't cover it too much when I filmed the initial video, so I wanted to interject it here into the video so you know at least what to look for and how to spot trouble so that you can replace this cover when you go back with your C6, if you need to. All right, next take off the modulator. ½ inch. So, like the servo, the modulator is always replaced on overhaul. All right, so you're gonna have your little plunger rod, and then of course the new modulator come with an O-ring. And then go ahead and withdraw your modulator valve. And what I like to do with these is I like to go, in and out with them, just kind of seeing if there's any sort of dragging or anything that feels weird. Again, it's just more of a diagnostic thing. So this is how it's orientated. Okay, this one does feel a little gritty to me, but that could just be a consequence of dirty fluid. I mean, who knows? When you go back with it, if it still feels that way, when you put a little WD-40 on it, then you're going to want to polish the bore with a bench buddy, and maybe even consider either polishing the valve itself or replacing the valve if it's real scored up. In fact, let me wipe this one off and we can take a look if that's an issue here. Okay, this one does have some scoring on it. It's what I would characterize as light scoring. This can probably be fixed up with a little bit of very fine grit sandpaper. I don't think it's the end of the world. Alright, extension housing. 9/16. Like I said, I'm going to see if I can get away with using a 14mm wobble socket. If not, then, I'll have to swap out my socket. Okay, note the little ID tag that was located here. So I'm not exactly sure what information that conveys, but the main casting ID stuff that I always look for, I already covered. So as long as you understand that, or it's legible and you know where the unit came from, that's the main thing. Okay, 6 bolts hold the extension housing on. All right, just make note if your transmission has a little, I guess, a electrical hanger or, you know, some sort of router, just make note of where it came from. And this one's going to get a little more difficult because there's so much crud on these bolts. Alright, you got two way down here at the bottom at roughly the 5 o'clock and 7 o'clock position. And the ones at the 5 and 7, the bolts are longer than all the other ones. Okay, so just keep track of that. Alright, then we're going to rip the trans mount off. So that's 3/4. And that trans mount has certainly seen better days. Nice. All right, always replace your rear transmission mount. If the transmission mount is allowed to wear and it wears enough, it'll introduce harmonic vibrations that can potentially damage the transmission, especially the rear gear train, and cause all kind of other issues. So engine mounts, transmission mounts, anything like that, you want to make sure that you always keep them in good shape, good serviceable shape. Replace them as you need to at whatever the recommended service intervals are. And I want to say, probably every 100,000 miles, I would check the engine mounts. Transmission mount maybe once every 50 or 70,000 miles, or just check it every time you do a transmission service, or basically anytime you're under the vehicle. All right, so the governor is going to be next. Gather up my bolts here. So 3/8, and unlike Chrysler governors, there's no through rod that would otherwise, need to be taken off before you take out the bolts. So just make note of the orientation. Okay, right now the vehicle's in park. Take it out of park so you can spin the output shaft around. And that's the other thing. Always spin your shafts. I mean, I say this in all my teardown videos. Spin your output shaft. Spin your input shaft. The output shaft is going to turn, take about maybe 4 to 5 times more force, spinning it in the opposite direction engine rotation, but either way, it should not bind up. There should not be any kind of grinding sounds, anything unusual that would lead you to believe that there is some sort of gear train issue or some other type of failure in the unit. And, I guess if you encounter that, then you're already prepared, and you're probably going to be into it for some gears. All right, so with the governor, you just want to make sure that all of these valves are moving nice and free. Okay, let me get a little screwdriver. So So you just want to check them. Okay. All right, we'll disassemble and go through this later, clean up everything, but that's kind of a preliminary check just to get an assessment for its general condition. And you know, like I said, the owner indicated that there was no shifting issues, no drivability symptoms that he observed, so presumably the governor's working fine. All right, I'm gonna get organized here on the bench, and then when we resume, we'll flip the pan over, take that off, and then kind of take the valve body off and proceed from there. All right, real quick before we flip the transmission over, you want to inspect your servo bore. I didn't mention it when I took the servo out, but I'll mention it now. Just clean it up. You're going to do your real inspection when the case is clean, you know, once it comes out of the jet wash, but you know, it's a good idea to just wipe it down now and, you know, take your finger and run it along the inside just to make sure that there's no obvious scratching, scoring, grooves, or anything like that cut into the bore, okay? All right, I'm gonna take this thing, flip it over. The customer told me he drilled a small hole in the pan to drain the fluid. We're gonna be installing an aftermarket D-pan on this thing, so just, I guess, an expedient way to get the fluid out without taking a bath in transmission fluid. There's the hole in question, so. All right, 1/2 inch on all these bolts. All right, and gather up all the bolts. Make sure we got them all. All right, when the pan is kind of, you know, held fast to the case, and I'm sure if you watch my other teardown videos, you've heard me say this, but you want to take flat blade screwdriver, preferably one that is not grooved, right? Nice and smooth. And then you want to go and right at a bore hole location on the pan side of the gasket and use that with a hammer to, you know, tap so that you can free the pan from the case. You never ever want to go in between the two bore hole locations, and you don't want to go on the case side either, because if you are going to reuse the pan and you go in between a bore hole location, let's just say there's a whole bunch of RTV holding this thing on and it's just, you know, really stuck on there, you do run the risk of damaging the sealing surface on the pan rail, and if that's the case, then the pan will never seal again. Now, if you do likewise, but it's at a bore hole location, obviously the bolt will, you know, completely flatten out that sealing surface when you go to reinstall it. So, all right. Here is the pan. Again, a little bit of water. That's from the pressure washing, not necessarily from exposure. You know, there is a fair amount of burnt clutch material in here. So, one or more applied elements in this thing is starting to go out. So, all of the deep pans come with the you know, deep pan pickup adapter. Should just come right out. All right. So this has to be transferred to the new deep pan, and the new deep pan is going to be dimensionally very similar to this. I think it's an extra maybe 1/2 quart in capacity, but it also has a drain plug, which is the main draw. Okay, valve bodies. There's a few different C6 valve bodies in existence. From what I understand, they're all interchangeable except for the green dot valve bodies, which were in 1 year only. So just be mindful of that. We're going to install a basic shift kit transgo into this this particular unit when we go back with it. So let me put this pan away and then we'll resume. All right, 3/8 bolt. So you have these two bolts here, these two bolts, these two bolts, and these two bolts, okay? Don't touch any of the other bolts. Right now, if you wanted to just replace the filter, obviously you'd have to take out all the rest of the bolts. All right, so hey, note here, the bolts that came out of these two locations are going to be a little bit longer than the other bolts. So So here's all your bolts. Okay, so there's no check balls on the underside of the valve body. It is kind of what I call a, either compound or dual stack assembly. Here's the valve body itself, and then here's your channel plate. The spacer plate is in between them, and then you have your manual valve and your kick down valve. So here are the levers for each. It's your manual valve and your kick down. So like I said, we have an open case design. Ford and Dodge have very similar architectures in terms of how the components are arranged, the general design and appearance and layout. So and I don't know if they, if there was any cooperation between them when it came to developing their respective 3 and 4 speed transmissions, but they are awfully similar to each other. So, all right, get this valve body out of the way. I have a full Ford C6 valve body disassembly assembly video. Shows the installation of the transgo shift kit, as well as a full case reassembly series out there. So if you're curious about how they all go back together, you can certainly check check those videos out. All right, so what I'm going to do now is I'm going to fire up the compressor, and we'll go ahead and do a case air check. I think I'm actually going to reinstall the servo. I probably shouldn't have taken it out. I'm going to see if I can reinstall that, and so that we can check the apply there as well. All right, so let me do that, and then we'll bring you back when we're ready to go. All right, so in addition to the servo, I also put the governor back on. Part of the air check procedure is to both test movement of the governor valves, clutch apply, and band apply. So you want to see, or hear, I should say, good clutch apply and release, good servo apply and release, and then for your governor, you want to make sure that you hear those valves move. I mean, that's really the main things you're looking to accomplish with any air check. So we'll do that now. So have everything labeled. This is going to be our direct clutch. It's our forward clutch. This is going to be our band apply, and then we have the to and from governor, and then we have our low reverse clutch. All right, so we'll start with the low reverse. All right, the other thing obviously you want to be careful of, as you just saw, is fluid just flying back out at you. You don't want it spraying in your face. So if you're doing this with valve body off, but the transmission still in the vehicle, obviously fluid's going to be dripping, but you want to have some safety glasses on or something to, you know, protect your face from fluid flying into it. All right, governor. Okay, you see the air coming out of here. All right, that's normal. That should not be interpreted as like a, you know, a problem or something, but you're testing this valve there. Okay. If it sounds like that, then you know you have good movement within the valves. So all right, this is not going to move. All the action is going to be on the other side. So low reverse again. All right, that's a sign of very, very good sealing integrity. You see that a whole bunch of fluid squirted out being displaced by trapped air because air was remaining in the circuit until I pulled the nozzle away. So the low reverse clutch should be healthy looking when we pull it out. The frictions should not show as burnt. So now we're going to do direct. And by the way, as far as problematic clutches in this transmission, really no different than most any other. The direct clutch is the most vulnerable. So let's see how it sounds. All right, that actually sounds pretty good. Okay, once I had the nozzle on the port correctly and it's sealing, it actually sounds like it would work if it was, you know, installed into a vehicle. All right, now we'll do forward. All right, again, same deal. It's retaining air. Air is staying trapped in the circuit until I remove the nozzle. Okay, and the air that you are hearing is whooshing out its backside of the nozzle. All right, so here's the apply for the band. All right, so what I do is I'll install this little hose because you have to get in there because of the way that the casting is. You have to have a good seal between the port and, you know, whatever you're using. So I'll go ahead and put air. All right, and again, it's going to want to force my little hose here, you know, out of the port. Okay, but that's good apply. So, you know, as the customer stated, this was working just fine, and the air check appears to bear that out. Now, once we look at the frictions, we'll see which ones are stressed, because I have a feeling that at least one of these clutch packs, or maybe the band, or, you know, some combination, has wear. We saw a whole bunch of material in the pan, so if the transmission was working, I would say it's probably on borrowed time, you know, or was on borrowed time. But it's in for overhaul. We'll refresh it, and you know, it'll be good to go once we're done with it. All right, let me reset, then we'll set up a dial indicator, and we'll do a check on the endplay and door travel. Okay, so dial indicator is set up on the input shaft. What you want to do before you actually put the dial indicator on is like take a small or medium-sized rubber mallet and smack the input shaft in. I mean, you don't need to be crazy with it, but just make sure it's fully seated as rearward as you can possibly get it. All right, so the spec here is going to be between 8 and 44 thousandths. That's the amount of travel it's tolerable. So I'm going to take, you know, a reasonably large flat blade screwdriver, stick it right in here behind the sun shell, and then I'm going to pry it rearward to force the sun shell and everything else forward, and take a reading on that indicator and see what it tells me. All right, so it looks like we're right at 42 thou, or maybe, I don't know, a third of a thousandths beyond 42. So we'll reset it. And let the dial indicator come to a stop. Reset that. We're back at 0. And we'll do it again. All right, this is giving us, looks like 45 thousandths. So we got two different readings, 42 and 45. So let's see if we can get a definitive reading on the third attempt. Okay, so that reset to 0, so that tells me that that last reading was probably the correct reading. It looks like 44 thou. It's going to do it one more time because I'd like to get two consecutive readings in a row to be the same measurement before I say, yeah, I'm good, that's the number I'm going to write down. And I'm moving it subtly. Doesn't take much. Okay, so we had 44 thousandths, we have 43 and maybe, I don't know, 7/10 thousandths. Just looking at the indicator by eye, where it's sitting between those two hash marks. So we are right at the upper end of the spec limit. So when I go back with this thing, more than likely I'm going to acquire a thrust washer that is one size up thicker than whatever's installed in here now. So there's a multitude of different thrust washers available, both in the factory and the aftermarket. You have, I want to say about 7 or 8 different thicknesses that you can install, for that thrust washer that goes right in behind the pump there on the base of the stator. And that's ultimately what governs the amount of travel you have. Now, one thing I'll make note is that you're also going to have some movement in the output shaft, inward and out. It has no bearing on front end play. This does not thrust against the front half of the transmission, so I mean, as you can see, there's really not any movement. I mean, I'm moving it by virtue of the fact that there's vibration happening as a result of me, messing around with the output shaft. But it's not like one of those scenarios where you have to set output shaft travel or rear gear train end play or anything like that, and then phase it with the front end play. It's just there's just one end play measurement for these transmissions. All right, gonna go ahead and reset, and then we'll resume the disassembly. All right, get the dial indicator out of the way. And these are just random, random nut and bolt, and then a piece of bar stock with a hole in it. That's all I'm using. If you're watching any of my other videos, you've seen this stuff before. All right, and at this point, you can remove the input shaft for the final time if you want. Get it out of the way. Of course, it's going to want to move around all over the place on us. Make note here in the kick down, for the lever in this recess, there's an O-ring, so don't forget the O-ring. All right, going to take off the band adjustment screw. It's 13/16. At this point, you don't need it. All right, it's always a good idea to do some preliminary air checks, so that's why you want to keep this on. Now, this nut gets replaced on overhaul, and I'm not going to be able to do that. There is a seal on the underside of it. All these nuts come in the kits, so let me see what socket size you're going to need for the adjustment screw itself. As you can see, it has a squared off end. The Dodges that I build take 5/16 star socket, and that will also work for the Fords. So 5/16 Craftsman, Snap-on, Cornwell, whomever. But that's what you want to use when you go back with the band adjustment screw so that you can perform your procedure. And the factory procedure has you tighten down the adjustment screw to 120 inch-pounds and then back it off 1.5 turns. And then from there you need to visually assess and determine if you need to, make any additional either inward or outward adjustment on that screw. If you watch my rebuild video, I kind of cover this, but that initial 1.5 turns should be considered a general guideline or starting point, not necessarily a final destination when it comes to band adjustment. There you kind of have to use your judgment in terms of what that band looks like, its relationship to the drum, what kind of slop or knot it has in it. But ideally, for band clearance to be just right, you want to have as minimal play as possible where the direct drum is still rotating freely underneath the band when the servo is not applied. So that's basically Ford C6 band adjustment for you. All right, so we'll remove our band struts. All right, notice that the large cutout on the passenger side strut faces the band lever, and then you have the small cutout that actually faces the band itself, and then likewise for the driver's side strut. So your band lever, which is this thing, is going to be coated, and it's going to have a letter indicating what the ratio is. Now, like I said, I'll put a chart that shows you all the different combinations that I'm aware of, both from the factory and the aftermarket. But the main takeaway when it comes to, if you're doing anything high performance and you start modifying the relationship between the strut and the lever and the servo that you want to run, you just don't want to get too aggressive. Sonics recommends that if you're going to run their billet servo and cover combination, that you do not use their FF lever. That is the most aggressive lever that they offer, and that combination puts you at risk of either breaking your band or, in real worst case scenarios under high power, high RPM, actually cracking the case. So you want to follow just kind of a general rule of thumb that the servo and the lever have to be phased in with respect to each other so that you have the right combination for your application. This is going to be a stock build, so we're not going to mess with any of that. We're just going to put a new band in, and we're going to reuse the existing lever. You can inspect it, but there's very rarely any of these that I see bad. They're just, if you get a lever that's either cracked, from, I guess, use and abuse or what have you, usually you'll see something here, but again, it's not anything that I've personally seen. It's more or less very, very rare, unusual circumstance where the lever is no good. Here's a close-up of the lever. So again, this is where you would typically see some wear here at the strut engagement points. This is a K code. Now Ford has levers that go up to code F. And so this K code, which I've seen once before, I believe these are aftermarket levers, so it's possible this trans has been worked on. There's a plug that's in the front of the, you can see it when you're looking, in the front of the transmission that retains it in, holds it in, and you can drive that out by driving the lever out. In most builds, it's not necessary unless you have reason to believe that either A, the lever needs to be replaced, B, you're replacing the lever because you're doing something performance oriented, or just reconfiguring, the whole apply circuit and, whole second gear and everything, or C, if it's obvious that the plug is leaking. So anyway, like I said, I'll put a chart that shows the different factory lever ratios, and I'll put a link to Sonics' website. They have a whole bunch of different ratios that they offer as well, including their FF lever, which again is the most aggressive ratio that I believe they offer, and that should not be used with their billet servo or anyone else's. It should be used with a factory servo of smaller diameter. Alright, gonna take off the servo again, and I want to point one other thing out that I didn't really mention initially. So I get the servo out, and you probably already know this, but in case you didn't, I'll go hunting for my socket. All right, come on. So when we talk about piston size, what we're really talking about is the inner diameter here in the cover and the diameter here on the outboard side of the piston. Because the inboard side serves to force, serves as a sealing area to force the piston back into the cover and off the band. Okay, so it is not, and of course I screw myself again here, it is not this diameter here that you're measuring your servo apply surface area by. This is the release side, and yeah, that's in there. All right, so it's going to be this diameter right here. This diameter is for release, and looks like as you can see how brittle it was, I tore a chunk out of it. Okay. No worries, that gets replaced on overhaul. So alright, gonna spin it back around again. It's not going to really interfere with anything, and this lever is not going to come out until the drums are out of the way. So ½ inch. That bolt was a little loose. Okay, all these bolts are all the same. Yeah, I should be able to wedge everything forward to get this pump out. Okay. Where you're prying is the exact same place that you put your screwdriver in, or location rather, when you did your front end plate check. Alright, so pump, direct drum. What I'm doing is I'm using the band to kind of stabilize the drums so that they don't just spill out, onto the case, potentially damaging it, or especially this area here. Alright, just grab your band, and we'll look at these parts individually in detail in a little bit. Here's your forward drum. Okay, and then you're going to have your ring gear or front hub. There's a thrust washer that goes here. Okay, that's basically on the front of the planet. Alright, there is no thrust washer here. Now, you wouldn't know that if you watched my part 2 of the Ford C6 rebuild series. I got a little overzealous with the thrust washers and I actually put a thrust washer there. As far as I know, there's been no harm done as a result of me doing that. And I don't know, it may have had a detrimental effect to the gear train, I'm not really sure, but basically this area here would get some splash, lube oil, but it would get most of its lube oil through the output shaft. Alright, and then you have your output shaft here, you have your snap ring retaining your planet, and then you have your low reverse frictions and steels. Alright, I'm just gonna sit all this on top of there for now. Like I said, we'll break all this down in detail in a little bit, but here's our band. As you can see, we have signs of aggressive wear here. This actually looks like what happens when you do have some moisture captured and kind of retained in the case. When I flip the case back over, we'll more closely examine that vent tube that sits on the top, because if that gets clogged, then moisture is going to remain inside the case after vehicles shut off, because while it's in operation, any water that does make it in there in the form of vapor usually will either boil off, okay, boil off and vent through that tube, or you know, it'll otherwise be consumed just during normal operations, so that it has no material effect on the transmission's function or health. But in this case, you know, we have a band that's looking like this. Okay, there may have been, you know, some of that going on. All right, at this point, you can take your kickdown lever out, get it out of the way. Now you have unobstructed access to the nut, so we'll deal with that last. Simple transmissions. I mean, really not a whole lot to them. They're fairly easy to work on. You know, you don't have too much in the way of any kind of like real onerous aspects of, you know, of assembly and whatnot. Okay, here's your rear planet. Also has a thrust washer. Alright, it's always a good idea to purchase thrust washer kits. These thrust washers seem to be in good shape, but I always like to replace them if I can. And like I said, I'm a little overeager sometimes with them, but you want to make sure that all your planets are in good shape. Okay, like usual, I mean, these are no different than any other planetary carrier that you'll ever inspect. You perform the exact same procedures. Okay, you check them for vertical play, you check them for side play, you check the body and the structure, make sure there's no signs of cracking, no heat damage, no bluing. If you see any of that, then I would just replace the whole thing. And as I mentioned earlier in the video, it's very popular to swap gear trains from E4ODs or 40100s into the C6, especially the steel planets, where you get a deeper ratio than the C6 originally came with. So factory ratios are, I want to say, 2.46 in first gear, 1.54 in second, no, 1.45 in second, and then of course thirds 1-to-1 direct. For the E4ODs and the 40100s, if you swap in the gear sets, it'll give you I want to say a 2.71 or 2.72 to 1 first gear and a 1.54 second gear, which is going to be a little bit more advantageous, especially for heavy duty trucks, working trucks, towing and hauling. Not to mention the steel planets are a little bit more durable than you know, the aluminum ones. Ditto for high performance, street strip, all out racing. You know, it is very, very, very rare to see a race prep transmission to have its original planets, unless they've been like super heavily modified. All right, we'll look at the front planet. You have your capture bearing. Okay, make sure that this bearing spins nice and free. All right, you want to inspect the teeth as well. Okay, I'll bring the other one back. I didn't really mention it, but check your splines in here. You don't want to see any signs of aggressive wear here. No cracking. Make sure that they're not going to strip when they go back in. I mean, that's really the main concern that you would have. And like I said, structure, just make sure there's no signs of aggressive scoring. Anything that you can really feel, like, you know, deep cuts, ridges, whatever, you want to just replace the planet. Okay, these are not hard to find. They're pretty much everywhere. Alright. So the pinion gears look good in the front. Here's the rear. These look good as well. I mean, these two planets look like they're in good shape. So, as always, wipe everything down, clean everything off, make sure that you do a very thorough inspection once you have all your parts free of old transmission fluid and grime and dirt and whatever. Okay, sun shell, your bushings obviously will be replaced. You want to inspect the sun gear for anything obvious. This is these gear sets. The whole gear train is referred to as a Simpson style gear train. In other words, you have one sun gear for both the front and the rear planetary carriers, and then you have two separate ring gears. The other kind of gear set that you'll see in transmissions, Ford transmissions specifically, are the Ravino style planetary gear sets, and those are such that the planetaries, both for the reaction and the output, as well as the two sun gears, are in one contiguous housing. So those are like your AODs, AODE 470, 75W, and then later in the 6R series, the 6R 60s, 80s, and 140s. So the C6 is largely the first of its kind, in terms of aluminum case and the architecture and design and layout of the drums and everything else. And the E4OD 4R100 that came after it are direct descendants. The 5R110 is also purely a Ford design, to my knowledge, and descended large part from the E4OD 4R100 line. Now, when you move into the 6Ls, or excuse me, the 6Rs, and yeah, the GM 6Ls as well, those are actually not indigenous to Ford Motor Company. Those designs were based on the ZF6 HP26, and both GM and Ford, under licensing from ZF, produced their respective 6R and 6L family of transmissions. GM making some more significant changes to the design to suit their needs. Ford, by comparison, stayed largely faithful to how the ZF transmissions are set up. So 6R 60s, 80s, and 140s follow that, that same general principle. I don't know about whatever 8 speeds. I'm not familiar with the 8 speeds of any manufacturer at this time. And then GM and Ford jointly developed the 10-speed units for use in their various vehicles. All right, snap ring for the output shaft. And then the output shaft will just come out. So you just want to be careful with the output shaft. Okay, and then you have your governor support. We'll dig into that a little bit later. All right, you have your ring gear. And of course, another thrust washer. So ring gear, just check your teeth and check your splines, and then check over the body. You can separate the ring gear itself from the hub. Okay, there's a snap ring there. All right, now you have your low reverse clutch pack along with your drum. Note the direction of rotation for the low roller assembly. It's always going to be clockwise, and then locks counterclockwise. Let's grab at that snap ring. And to what extent the clocking of this snap ring is critical, I'll be honest, I don't know. I don't think it is. I mean, I've installed this, any old which way. If you're, super concerned about it, then, the best thing to do is just make note of where it was clocked in terms of the two ends, and then install it in the same exact orientation. Okay, here is your drum with your low roller assembly. Okay, this is on in manual low. All right, you'll notice there's two snap rings here. Okay, when we go back with these, I guess you could reuse it if you're confident that it's in good shape, but I never do. What we do now is we replace these original factory C6 one-way clutches with the E4OD 4R100 Borg Warner assemblies, and they're plastic. And they're also taller, so you eliminate the snap rings. You don't put them back in. You just simply sit the roller clutch inside. It'll stay there, and then you just, put this back on. All right, let's look at our clutch pack. It did apply. It did release like normal. Okay, so 4 frictions, 4 steels on a cushion plate. So check your backing plate or your apply plate. All right, no sign to damage. This thing's in perfect shape. Okay, our frictions, our steels, no signs of slippage of any kind. Okay, wipe this one off. All right, this is the bottom steel. The steels look perfectly fine to reuse. There's no harm in reusing steel plates. There is a harm in reusing frictions. I would never ever do that. Alright, we'll wipe this one off. So, very light scoring is evident. Very, very minor slip marks. I mean, a little bit of prep work on these things with like a wafer pad, and you know, they'll be as good as new. I don't know why I'm drying that off. Okay, so far so good with respect to the case. Get this out of the way. Okay, now we have our low reverse assembly. So, I mean, you can compress it if you want, but the best thing to do is just you know, take everything off of the back of the case, governor support, and then the race, which is secured by I think 4 or 5 bolts. All right, so let me get a little bit organized here on the bench, and then we'll flip this case around, take off the back, you know, everything that's on the back of it, get rid of the linkage, and then I'll be done for the case, and then we'll take a closer look at the drums and everything else. Probably want to yank off that selector shaft nut, 7/8. And it's going to be a little bit of resistance because you have your parking mechanism still installed, or at least if you're tearing it down the way I am, that'll still be installed, so it's not going to just slide off. Main thing you want to do with respect to the parking linkage and the selector and all that stuff is just simply the relationship between all these parts. So, and obviously, you know, taking a picture goes a long way in accomplishing that. So that has to be cleaned off. Okay, then you have your selector seal. Ford makes a special tool to, you know, remove these seals and install them. There's a, you know, literally a specially bushing driver, or seal driver rather. There we go. That one was stubborn. And that bushing driver in particular is this thing, and you may have seen me use this on other, you know, other selector seals. I'm looking for a tool number or something. If I find it, I'll annotate the video. All right. Spin the rest of it around. All right, so now we have our governor support, governor tubes, and then the rest of our parking linkage. All right, so here is the rooster comb and the manual valve, secured by a C-clamp, or C-clip rather, C-clamp, C-clip. All right, that's how it went in the case, just like this. I mean, if there's anything overly complicated about the C6, anything at all, it would be the parking mechanism, and only because it's more complicated by comparison relative to everything else in the case. Okay, so 1/2 inch on these bolts. And they're all the same. Looks like I got a glove that I need to replace. Alright, so this is going to be kind of held fast with the tubes here, so you just want to carefully, and I mean carefully, kind of pry outward. You don't want to force anything. I mean, they'll come out, but because they're kind of shaped, you know, in a way that it's difficult to just, you know, get in there and pry, you want to be careful. Alright. Not an ideal result, but, you know, it worked. Alright, so for the governor support, okay, you're going to have the longer tube. It's going to be inboard, if you will, relative to, you know, left, right. It's going to be to the left, and the shorter tube is going to be to the right. Alright, so don't bend those up. So the main thing here is you want to make sure that there is no ridges or grooves cut into the sealing surface by the sealing rings, all right, on the governor support. So this is really the governor support housing. If you have that problem, then you're going to want to replace this. If the scoring is super light, like you could feel it but barely, you can clean it up with a little sandpaper. I mean, they'll seal, but if you know, it's where it's like real distinct. I mean, you can clearly see a ridge or a valley or whatever the case may be, then you'll want to replace this. Alright, your parking gear and the case thrust washer. Alright, so, you know, it just goes like that. So for the parking gear and the pole, you actually want to take a little time to inspect these. So you want to inspect your pin, your pole, and then you have the guide plate here, which I guess I can yank that off real quick. You want to inspect all these parts. The guide plates are, I mean, I don't think I've ever seen one even close to being bad. But the pins can get a little messed up every once in a great while, and that usually coincides with parking pole damage. Okay, so if you live in like a mountainous area where there's a lot of grades, and you know, I would say not that you would ever do this, but you know, if you're building transmissions and you see one of these come in where either the parking gear is cracked, the pole is broken, it's usually because people are parking their vehicles on grades, and then either they don't have an e-brake that works, or they're not using it. Either way, they're letting the entire weight on the vehicle slam into the parking pole and gear, and so the parking pole gets incredibly stressed. And I've seen every so often either a C6, E4, D4, 100 come in, and this will be broken. So you want to make sure that this is in good condition. Okay, none of the lugs there's no fissures or cracks, fractures, or fault lines. Obviously, you want to make sure the splines are in good shape. You want to make sure the thrust surfaces are in good shape. You can modify these, have a machine to accept a bearing. You know, that's something you can do if you wanted to, you know, make a little bit more how do I say this, fluid dynamic in the back here, you know, a little bit less wear, and also mitigate heat to an extent. Anytime you can replace a static thrust surface like this, all right, with a bearing, then you know you're going to be able to mitigate heat. So all right, so that's the governor housing or support housing. And then you have your spring and then your pin. All right, let me get these out of the way. Now you have your remaining bolts, so 7/16 on these. So when you go back with the unit, you'll have to use a return spring compressor for the C64 D4100s so that you can compress the race and the return spring rather, so that you can seat the race and the snap ring on the case and install the snap ring. There's a snap ring that's going to come out. All right, because I don't want this thing just crashing into the case. I'm going to hold my hand here. All right, all these bolts are the same length. And the hands are real slippery, so okay, here is your snap ring and your race. Note the orientation of the lube hole. Okay, it's going to be at roughly the 5 o'clock position. Here's your return spring. Make sure it's, none of the springs are missing or broken. Make sure that the housing itself's in good shape. So I'll just look at it real quick. All right, for your inner race. All right, make sure, again, a lot of this is common sense. Make sure that there's no fracturing or chipping. Here we see something right here. See that? Not exactly sure what that is. And it looks like a chip, actually. So I may be able to clean that up. It may not be consequential, or I may decide to replace it. So, like I always tell people, when in doubt, just swap it out. Alright, you want to shoot some brake cleaner into this lube port here and in here, just to make sure that there's no obstructions. If you install this wrong, and I think you can install it such that this is not clocked relative to the lube port in the case, but it'll still bolt on, then obviously you're going to have real problems in the back. You're going to burn both of these bushings up. You'll have contact here between the bushings and the output shaft. They'll walk. The bushings will walk, or they'll just kind of disintegrate. And then the whole rear of the case, what usually happens is the whole rear of the case warps, and you'll be able to not install any new bushings, and then you'll have to replace the case. It's more common in the E40s, 4100s, to where the rear of the case is warped. Sometimes in high performance, especially in diesel applications, you'll have a bushing walk issue, and a diesel case for a 4100, for example, is like $600–700 by itself. They're very, very difficult to find. So again, you always want to make sure that that lube hole is is clocked correctly on the race relative to the corresponding hole in the case. There's other reasons for burn up back there too, not just the lube hole, but that's a surefire way to do a lot of damage in the rear if you don't get that part right. All right, as far as guidance on overhaul with these bushings, I never reuse the factory bushing setup. It's a waste of time and money. Sonex makes a one-piece bushing for this area. It just goes right in, covers the entire bore, and you see me install that on the C64D or 4100 rebuild series that I have if you watch them. But that's what I would recommend. I would never reinstall factory 2 bushings in here like you see it. All right, the last thing that's really in this case is going to be the, what do you call it, detent, your detent spring, the roller. So if I can get it upside down, and then you have your low reverse piston. So here's the detent roller. I'm going to take it out just because, well, why not? And I want to say it's 5/16. Yeah, it's 5/16. So 5/16 on that. Let me grab an adapter. And then we'll turn the case inverted so we can get that piston out of there. Detent roller, a little bolt. Yeah, you don't have to take, like I said, you don't have to take the lever out. I mean, you can if you want. It's up to you. And a little bit of residual water in here. And like I said, the customer had advised he pressure washed the case, which was nice of him. I appreciate that. Get a lot of the dirt and grime off of it before it came in. So, it'll be up to us to remove the rest of it. Stuff out of the way. Oops. And we got some of the kibbles and bits that are sitting in the bottom of that bell housing, moving around and dropping to the bench. All right. Some of this fluid drain out of here. All right, low reverse piston. Okay. It's got 2 sealing rings or seals, or square cut seals, whatever you want to call them. We did not have any issues with apply for this clutch pack, so that sealing ring or lip seal or whatever, like I said, whatever the hell you want to call it, is in good shape. Usually it's not the outer perimeter seals, it's the ones inside on these low reverse pistons. And when I say these, I'm not talking about just this, C6. I'm talking about any transmission that has a low reverse piston in it. And so, if you're going to have an issue, usually, at least in my experience, usually it's the inner seal, the inboard-most seal. If it's got 3 seals, it's going to be the one in the middle. For the forwards, it's going to be the one inside, and this one is no different. As you can see, it is very hard to get out, and sometimes you just kind of have to break it in half with a pick like this to get it out of there. All right. Okay, that's damn near rock hard, and then you compare the outer seal, which is still nice and supple. So this circuit was sealing only partially. The clutch eventually would have started to slip, so customer was right to have this brought in. It's kind of right on the edge of starting to malfunction. We got a band that looks like it's been through like World Wars III and IV. We got seals that are hardened and dried out. So let's start going through the rest of the sub-assemblies. Let me first get this case out of the way so we have some room, and then we'll start tearing through the pump and the 2 drums, take a little bit closer look at the rest of the gear train, and then we'll wrap up. Alright, case is out of the way. Got a fresh glove on, so we'll go ahead and proceed with the pump. Now this gasket is all falling apart. So if the gasket was actually intact, we just take a quick peek around it, make sure that nothing was blown out. Basically what I like to do is just see if there's any indications that there was like high line pressure anywhere. That's not super common in the C6. You see it more in certain GM transmissions, but it's always good to take a look. All right, 1/2 inch on these bolts. Let's turn it this way. Okay, all these bolts are the same. All right, got a little bit of water in the pump gear area. I'll wipe it off so we can take a closer look at it. So here's our selective washer. Like I said, when we go back with this thing, I'm gonna install one that's maybe one size up in terms of thickness. So these are color coded and numbered. This is a number 2. Okay, number 2. So that will likely not go back in. All right, so for the stator, like anything else, you want to check here. Now, what you see here is relatively common with respect to wear patterns on the stator. All right, I see this fairly frequently, this kind of bronzish material. It's basically bushing material transfer. And you'll get this when you have I guess a couple of conditions. One, when the bushing begins to wear, the stator will, kind of start making harder contact with it, and you get some little bit of material transfer and a little bit of staining in the stators. The other cause is electrolysis, where you have a short to ground somewhere in the vehicle's electrical system, and it's actually grounding itself somewhere on the transmission. And usually, if we're going to see that, you see it on the yoke that goes in the back, in the output shaft. You'll see rear bushing, extension housing bushing material there on the two-wheel drive units. You'll see it on the selector. So selector shaft, it'll have like a kind of like a same kind of I guess appearance in terms of stain and or wear pattern. You'll notice it there. The vehicle's grounding itself on the selector, or in the area of the neutral safety switch. So you just want to look out for that. I don't believe this is the case, unless this thing has had some water in it, and water and electricity, kind of like a unholy alliance, so to speak. So I'll talk to him about that and see what he says. So we got pieces of gasket material. When it's bonded to the casting like this, the gasket usually indicates some overheating. It's not uncommon to have, occasionally an overheating episode occur, and all it really takes is one for this sort of thing to happen. All right, what I'm going to do is I'm going to mark these gears. All right, I like to do this because if the gears are in good shape, then there's not any reason to not reuse them. So this will just preserve the relationship. How critical this is, I'll be honest, I couldn't tell you. It's just something I've always done. I'm getting lint all over the gear. Alright, so here's our drive gear. When you have a converter hub style such as this, where you have flats, a main area of concern is this area of the flat likes to get, kind of bulged out or bent up. It'll roll and fold over, and what'll happen is you'll have a problem engaging the converter. It just simply won't go on. All right, so you see there's a little bit of wear there on this side. All right, so the flats go all the way to the top on the inboard side of the housing. So And again, it's another reason why you may want to mark it if you don't already know all this. You just know that your marks will line up and you know that's the right orientation. This gear looks a little questionable to me, so it might get replaced along with this one. I mean, you never replace just one of these gears, you replace both of them. Okay, for the driven gear, you want to inspect this outer surface here. It's okay if it has some visual wear patterns like this one does, but when you run your fingernail up and down, it should not get caught on any of the, anywhere along the surface. If it does, then I would replace the gear. And again, you're replacing as a match set. This actually feels like it's got some wear to it, so we're going to have him replace these gears. Alright, now, assuming that your gear set passed a visual inspection and everything looked perfect, or at least to the point where you have no concerns, then your next step would be to assess clearance. Okay, so first things first, inspect the crescent. All right, most of these pumps are, this design are fairly resilient. So your, this transmission, your TH350s and 400s, it actually takes a fair amount of wear to cause these things to not produce sufficient pressure during the course of operation. But the one thing that will take them out of circulation and out of action super quick is aggressive wear on the crescent. If that's worn, okay, and either of these surfaces, particularly on the ends, are worn, then you're going to have a pump that's going to struggle to meet pressure demands, especially in any kind of performance application or a heavy-duty towing, hauling, or working truck. A lot of these transmissions are in old school plow trucks, and they're plowing snow, and I mean that's a extremely hard use type of environment. So your pump has to be in tip-top shape if you want to have a transmission that's going to survive. All right, this pump O-ring still feels fairly supple. It's just being stubborn, or I just don't know what the hell I'm doing. Okay, it's in there. Yeah, I mean it's starting to harden up though. Alright, we'll just put some brake cleaner in there so we can remove all this old transmission fluid and get a closer look at everything. Hey, like I said, you wouldn't really be doing serious inspection right now anyway. You would be, this would go into the jet wash. Once it's out, then you would take a hard look at it, with a critical eye, because then it would be nice and clean. Okay, bushing obviously gets replaced. One thing that you absolutely must know with respect to the bushing, okay, C6, E4OD, 40100, they're all the same. You'll notice here the oil groove. The oil groove does not go from one end of the bushing to the other. Okay, it stops about, I don't know, 1/4 of an inch from the front edge of the bushing. So you want to make sure that when you go back with your new bushing, the new bushing oil groove is oriented in the exact same way. Okay, it doesn't matter where, in terms of like here it's in this location. If I made a mark and then I put it here on reinstallation, that's fine. But if I put this bushing in backwards, then all the fluid is going to be channeled toward the front of the seal. I should say the back of the seal. It'll overwhelm your drain back capacity and it'll blow your seal out. So whatever you do, make absolutely sure that you install your bushing for the pump body in the correct orientation. Okay, popping the seal out is fairly simple deal. Okay, out it comes. And then you can inspect this area in here. Alright, the other concern with these is the staking. You want to make sure you stake this bushing. You don't want to have any risk that it walks on you. All right, there's the drain back. So the working surface must not be scored heavily. If you got very light scoring, that is not the end of the world. Okay, despite what anybody tells you, at least in a factory or very mild application, in a high performance, heavy duty, you know, a lot of RPM or a lot of, you know, hard and heavy towing, big engine power, the pump probably should just be completely worked over and remachined. But you want to check here and make sure that there's no heavy scoring in, you know, on the working surfaces. Okay, check the perimeter here, the inner diameter. Make sure that there is no scoring that would concern you. As you can see, there is some wear. Okay, you have a wear pattern. So when you see a wear pattern like this, run your fingers. Okay, I can't really feel anything. Like I said, I'm going to really eyeball this whole pump. I don't think I'll have to replace the body or the stator, but you know, because it's still kind of filthy, I want to make sure that it's spotless before I really make a final decision, so I can inspect it through and through. I'll get this bushing out of here, and then I'll be able to tell whether or not this is viable. But you know, on its face, based on what I'm seeing right now in terms of the wear, you know, like this, for example, you see that, you know, kind of parting line. All right, I cannot actually feel anything there. So, in my initial assessment, I think this pump's okay, but I won't make a final decision until after everything's cleaned off. All right, so I'm kind of gonna go out of order with stuff. I mean, it's not gonna be as it was in the case, so it's gonna be as it was piled up on the other side of the bend. All right, so like I said, we are gonna remove these snap rings because the replacement sprag, or roller clutch assembly rather, is not going to need them. It won't fit if they're in there. So this is like a semi-captured assembly. I mean, somewhat similar to the Dodges, except not quite as egregious when it comes to reinstallation, but it's another positive aspect about using the Borg-Warner E4 D4 low roller assembly is you don't have to deal with any of that crap. All right, with respect to the drum, you want to check the cam surface, make sure it's in good shape. You don't want to see any indication that a roller might actually roll over, or you know, where it's not going to allow the clutch to hold in the counterclockwise direction. So if you see anything that concerns you, just simply replace it. Again, these parts are not overly difficult to come by. So other than that, it's a, you know, pretty straightforward inspection process. You're just looking for any signs of damage, cracking, excessive scoring here on the lugs. The main thing is with respect to the lugs is you don't want a situation where, you know, you got a clutch disc and that clutch disc can't slide freely. Okay, like if there's some sort of divots or, you know, chips, fractures. So then if it gets caught up, and then you're going to have a no apply situation in reverse, and you don't want that. Or manual low too, since this is low reverse. Socket's falling into the gutter there. All right, I'm going to set my gears off to the side. Low reverse piston. You're just going to check, make sure it's not cracking. I don't know how common it is for that to actually occur. I've never personally seen it. Not like I've done thousands and thousands of these, but you know, like anything else, you want to make sure you can reuse it. Okay, we talked about the race. All right, so here's the sun shell. So I'm going to separate the shell from the sun gear. or more accurately, I'm going to try. If you watched any of my other videos featuring, these styles, wire type snap rings, my track record with them has been abysmal in that I struggle to get them off. This is probably going to be no different. So TH350s, Chrysler transmissions, these, they all kind of have these kind of wiry, pain in the ass snap rings that just like to bedevil me. And this one seems like it's particularly ornery. All right. Problem is getting this snap ring such that it's expanded wide enough to take it over the shell. I'm sorry, take it over the gear. Because it absolutely does not want to go. And yeah, on one hand, it's a good thing because you don't want to have a situation where your sun gear is going to separate from the shell, but at the same token, you're trying to film teardown videos, and you're going to want to look like you know what you're doing. It'll really frustrate you. And I really shouldn't apply that to anyone else but me. I mean, you guys watching this are probably like, Jesus, I can get this off in like 5 seconds or less. And here you're taking 5 hours or more. All right. All right, it was way too difficult, more so than it needed to be. So you're going to have your thrust plate and then your shell. Okay, the inner portion, there's no thrust plate. So the shell's a hard part. You can buy, hardened high-performance shells. You can also buy just factory equivalent replacements. Alright, so again, check your splines in here. Okay, make sure that there's no obvious signs of damage or anything that would lead you to believe that they may strip when you go back with it. Okay, check your lugs. Alright, they should not be aggressively worn. I mean, you can repair these if you're handy with a welder. You TIG weld a whole bunch of material on the worn side, and then you just machine it down to spec, and you're good to go. But I mean, for most folks, it's not worth the effort of the time. I mean, I have no idea how I would do that. I don't weld, so for me, I would just replace the shell if it needed to be replaced. Okay, bushings in the sun gear get replaced. So you just want to check your teeth. Okay, notice there is an indexing groove here on this side that's not present on this side. There's no need to remove this snap ring here. Alright, it's just completely unnecessary. Check your face. You see some very minor little imperfections there. Nothing to worry about. Alright. So the sun shell looks good, the sun gear looks good. Alright, we talked about the hub, looked at that, that looks fine. Alright, so let's take a look at our forward drum. Alright, so always assess your clearance on teardown, and I recommend, again, if you're not familiar with a given transmission, you don't do them all that often, don't throw your steels and frictions away, especially if they're still in good shape. You want to make sure you have them for reference in the event when you go back with it and you got a wildly different clearance figure for your pack on reassembly that you did when you took it apart. You want to be able to true back to those clutches and see if there's any major differences, anything that's important that could help you understand why all of a sudden it's so different. Alright, these snap rings are selective. I'll put a chart that will give you a breakdown of every thickness that's available. So this is your forward clutch pack. You have your apply plate. You have your cushion plate, your bottom steel, and then you have your 4 frictions and your 3 flat steels and your backing plate. Okay, a little bit of slip marks here on the steels, nothing overly concerning. Okay, you can see the frictions got a little hot. So this is the bottom friction. It is worn. There's your steel. It looks better on that side. Second friction, not as worn. Your third friction, or excuse me, third steel, a little bit of slippage. A little bit of wear on the third friction. And then you see more slip marks. So this transmission is definitely in the back half of its life. I would venture to guess that it would have needed to come off the road within, I would say, no more than about 5,000 miles max. These frictions are worn. The band is completely shot. It would have still functioned, but I mean, it was pretty chewed up. All right, you got your 3-tab washer here. All right, so just check it. It's not selective. Just make sure it's in good shape. That's basically it. All right, here's your Belleville style plate. Looks like I'm in need of a new glove already. And this will be stubborn. I mean, it's not going to want to come out willingly. You just got to get a screwdriver underneath it. And just start working it out. And of course, it'll want to get caught in the clutch snap ring groove. You want to make note of the differences between the two of them. You'll notice that the clutch snap ring has only one end that's intended like that, and then you have a squared off end. For the Belleville snap ring groove, you have both ends that are notched. All right, you got your steel support. Goes right there in the pocket in the piston. All right, on the back of the drum, you're going to have your sealing rings, and then of course there's a thrust washer here for the direct drum. And you have your bearing. All right, check your bearing. Make sure it spins freely. Make sure it doesn't make any unusual sounds or feel like it's got sand in it or whatever. This feels fine. And then note that the back side of the bearing is the bearing half, that's outboard. This is the inner half that faces up when you go to reinstall it. All right, and then you have your lip seal here on the perimeter of the piston. So like all pistons with a bleeder ball, Make sure it works. If not, shoot a whole bunch of brake cleaner and check it again. It's very rare I see them actually bad. But if it will not move and this ball is seized, then you're definitely going to want to replace the piston. Okay, just make note of the part number. So if you're not familiar with these transmissions or really any other, it's a good idea not to actually remove the lip seal. You know, if you're not sure. So here's the lip seal. It's still fairly supple. I'm actually going to put it back on. Just wanted to pull it off to check it. I mean, this clutch did apply, so you know it was working when the trans was in the vehicle. Like I said, customer told me that it worked fine. There was no drivability symptoms that he observed. Okay, next is going to be the O-ring on the stator and the drum. So here, also feels fine. Alright, check the drum itself. These are basically powdered metal. So if you're doing anything super high performance, high RPM, a lot of power, it's very strongly recommended you go with a billet forward drum. Okay, because these will crack under, you know, any kind of real serious torque demand or real serious, you know, high RPMs. Alright, just check your lugs. Check the sealing surface on the inside where the lip seal goes. You know, check the journal in here too. Alright. And then for that piston, you know, check the sealing surface in here. Okay, there should be not any signs of scoring, any damage of any nature or sort. I mean, if you've watched enough of at least my teardown videos, it's really the same themes reoccurring throughout. So, you know, if you watch these videos, either mine or other channels, or you know, you just frequently watch these videos, after a while, it'll almost be like you have done one of these transmissions, or at least torn them down to where you know what to look for, and that's right. That's the idea, right? So, same basic stuff. Not really anything different. When it comes to what you're looking for and given transmission internal parts. Alright, let's see what kind of drum we have in here. This is a direct drum. So here's our 4-tab washer that goes there. So these drums were either 3-clutch or 4-clutch. And don't quote me on this, I think there was some 5-clutch direct drums as well in the real specialized applications. I think Lincoln had 4-clutch direct drums in those cars. All right, so here's your direct clutch snap ring. So we got 3 frictions and 3 steels and our backing plate. So a lot of heat has been introduced into this clutch. Okay, this is the bottom steel. You can see the heat marks. Okay, frictions are worn. A lot of heavy slippage, so most of the material that we saw in the pan came from this clutch pack, and to some extent the band. Let's wipe off the backing plate, make sure it's in good shape. It's not too bad. Can use prep work, but other than that, I don't have any concerns about it. So we will be replacing the steels in this clutch. These are no good. I would not reuse them. The danger of reusing steels that have, you know, roughly this amount of overheating or worse is that they're no longer flat, and it really doesn't make any sense, or it's not really worth your time to figure out if they're flat or not. You know, if they have all kind of slippage and signs of overheating like this, it's just that much easier to get rid of them and, you know, replace them with steels that are brand new. Okay, here's your direct clutch. Let me go ahead and take the snap ring out on the foot press, and then we'll look at the piston and the return springs. Alright, note the position of the snap ring relative to the locking bosses. Like all of these return spring assemblies and drums that have locking bosses, you want to make sure that when you go back with it, you have all 4 points of contact, just like you see it here. Alright, so what you want to do is you want to observe the pattern of the return springs. I would say most of these drums do not have all of the springs installed, so this is going to be mostly a stock unit. We're not doing anything, real performance oriented, so just going to follow this pattern that you see here. So 3 and 3, and then 2, and then 1 and 1. Take a picture of it if that helps, but that's what you want to do when you're dealing with these drums. So not a major deal. As long as you keep track of everything, you won't have issues. Alright, here are return springs, snap ring, and then let's withdraw the piston. And of course it doesn't want to come out. Okay. You have another square cut seal here. And just handling it, it's starting to harden. I mean, it's still supple in some respects, but it's clearly seen better days. Then you have a lip seal down here at the base of the drum. If I can get it out. That's really in there. And it's causing me a mess up my glove. Okay. And again, it's another square cut seal. It's not necessarily a lip seal. Also starting to harden, particularly right in this spot here. All right, 2 bushings in the direct drum. They're to be replaced. Okay, one last thing with the direct drum, you want to make sure that the band surface is in good shape. So just check it all the way around. All right, you don't want to see any kind of gouges, any serious heat damage or anything else. You can also use your straight edge. So let me go grab one. See the old straight edge and flashlight technique? So all you're going to do is just put your straight edge right there on the surface and then shine a flashlight right underneath, or right down behind it. If you see any light peeking through, then you know that you probably have a warp condition. Now I'm doing a poor job of this because I'm trying to do this at the same time and the camera is where I would normally be. Let me see if I can hold it steady. Okay, just like this. So this drum appears to be in good shape overall. No real issues with it. Check these lugs too. Okay, if there's a lot of wear on the lugs and the sun shell, then you'll occasionally get excessive wear here on each of the contact surfaces where it's reacting with the shell. So check this area here too. Basically, you're just doing a structural examination. You want to make sure that this drum and the forward drum are both in good shape to reuse and that there's not going to be any issues. Again, real high performance, you want to upgrade to billet drums. Anything that's going to see super high RPM, again, that's the recurring theme. I always stress it because, factory drums, by and large, and that's, GM, Ford, Dodge, foreign makes, whatever, they have their design limits. So you want to make sure that if you are going back with a real high performance build, and you're going to exceed those design limits with either power, torque, or RPM, you get drums that, can withstand in that environment and thrive, so to speak, right? You don't want any kind of catastrophic failures happening to you. Okay, check the wear here in the ceiling ring groove area. So you want to make sure that there's no grooves cut in. Like I said, it's okay to see the wear pattern, but you should not feel anything. If you feel anything, then this drum's no good and it needs to be replaced. And one last thing I'll make mention of when it comes to the direct drum, you have the 3 clutch and the 4 clutch drums. 4 clutch is ideal for anything, mild to moderate performance. I mean, 3 clutch will work too, but you want a 4 clutch. Now, there is some folks out there that will machine the drum to accept a 4 clutch style setup by cutting an additional snap ring groove toward the, top of the drum. An additional groove up here on the top of the factory groove. You could do that. It's perfectly fine. The main thing is obviously either you or your machinist know what they're doing, but you can run an additional clutch and steel, an additional snap ring. In fact, I think that you can probably squeeze an additional 2 frictions and steels in there if you machine the drum accordingly. I haven't had to do it. The 4 clutch drums that I've used in these are fine, but again, I'm not going to pretend that I've seen every possible combination or application when it comes to C6, so that is an option for you if you are building up a more serious build and you need that additional surface area for strength and holding power. The one thing I would not be tempted to do is install a forward apply plate into the direct clutch. I've seen some folks on the internet talk about doing this to squeeze an additional friction and steel in there, but these are not really meant for that. They're not meant to take load, shifting load, if you will, where you have a transition from second to third and you have a lot of torque in high gear. I have heard of folks doing this and these plates just simply breaking in half in real high horsepower applications. So it's not something I'd recommend. Obviously, it's your transmission. If you want to do it, then go for it. But I've never done it. Again, there hasn't been a need, to do anything like this. So it's just I wanted to make mention of it because every once in a while we'll see folks talking about doing it, and I would say exercise caution. And if you can, either have your existing drum machine swap to a 4 clutch direct drum, or buy an aftermarket performance drum. Get this stuff out of the way. Alright, I think the last piece we're going to look at is the governor and governor housing. And we looked at it a little bit in the beginning of the video, but we'll take one last look at it before we adjourn. All right, governor, we talked about that. Just again, go through it, make sure everything's moving freely, nothing's bound up, nothing's catching. If you have that problem, obviously, then you're going to have drivability symptoms, issue shifting, upshifting, downshifting, etc. I gotta quick grab another glove. So no upshift conditions. The governor occasionally modulator, it could be valve body as well. So a lot of these old transmissions, it's going to be either governor, modulator, valve body, or detent system / kickdown system. So, and kickdown system could be perceived as a subset of the valve body. All right, so you have a snap ring here that has to come off. And I am not having the greatest of days when it comes to snap rings. All right. So just scrutinize your output shaft, make sure that all the splines are in good shape. Make sure the snap ring grooves, there's no issues with any excessive wear that would lead you to believe that the snap ring can possibly pop out. All right. So you have your scarf cut sealing rings here. There's 3 of them. They come in the kit. They'll be replaced. All right. Check the body itself. Again, splines in here. Check the face. If you wanted to go so far as using a straight edge to confirm that this surface is truly flat, I mean, it can't hurt. Always, it always helps to double check. And then just check your sealing ring grooves. You want to make sure that all these sealing rings move and rotate freely. Okay, just like that. If for whatever reason they were to become bound up, they'll start cutting deep, ridges and deep channels into the governor housing. And I'm not gonna lie, I've not seen anything like that. But then again, I'm sure somebody has. All right, so that is the teardown inspection of this particular C6. So in summary, this is gonna take a full cowl kit. We're also going to do steels in the direct clutch, a band, a filter, paper and rubber. So cowl kits basically all of those things except for the steel module. Also include a bushing for usually the pump body. So we'll do a complete bushing kit as well along with a thrust washer kit. I'm going to need a thicker selective washer for the pump. That endplay is pretty much right on the edge. I may not need it if thrust washers end up, shrinking that spacing a little bit. Sometimes that happens, though it's not going to be any significant amount, maybe a couple thou at most. So definitely going to acquire what we need there to make sure that endplay is where it needs to be. As far as pump gears, we'll replace those. I'll do a separate video to show you how to measure and validate pump to gear to deck surface clearance and all that good stuff, so that you see that. I didn't do it here because I'm 99% sure I'm going to be replacing that gear set, so there was no point. Servo, we need a new servo. We need to inform the counterman what servo code we have. That's an N servo. So I think I pointed it out earlier, but if not, it's going to be right here. You're always going to find it in the little piece of the pie that's closest to this location, so it's right in there. I mean, it's caked with mud and dirt, but it's there. Cowl kit for these transmissions will also include a new modulator, so we'll get a new vacuum modulator on there. Everything else for the most part looks in pretty good shape. Can't really complain. I think he made the right call to bring this in. It was right on the edge of taking a dump on him. So, he'll be happy to know that, he caught it just in time, and that when it goes back together, it'll be good to go. I mean, he originally wanted to install and have built an E4OD, but after, we went through the numbers and all the costs and, the complexity involved in modifying the, vehicle and drivetrain and all that stuff to take it, we decided against it, and he elected to move forward with a C6 build. So, Anyway, thanks so much for watching. If you have any questions, comments, go ahead and leave them below. If there's anything specific you'd like me to delve into with respect to the C6, or any particular aspect of the transmission you want more information about, let me know in the comments so that if I can, I'll put together a video and post it there on the channel for you. Other than that, as always, enjoy the rest of your day or evening. Thank you so much again for watching, and we'll catch you on the next video.